All right, so let's go ahead and cover the concept of compound inequalities. So a compound inequality is a combination of two or more simple inequalities. And there are basically two types. There are compound inequalities and there are ors. So to kind of understand that better, let's just take a look at these two examples here in the blue and the red. So if we look in the blue, right, I have these two simple inequalities here. X is greater than 2, and I also have x is less than 9. So think about that. Is it possible for x to be greater than 2 and less than 9 at the same time? Sure it is. If x was 4, it would be greater than 2 and less than 9. So this is an example of a compound inequality that is an and. And so in order to combine these two, I could write them together like this. I'm going to put the x in the middle, and I'm going to say what x is greater than 2 and less than 9. So this is how it looks. And again, you're going to read it from the inside out, from the middle. So x is greater than 2 and less than 9. And again, this is called an and situation because x can be both greater than 2 and less than 9 at the same time. Look at this example next to it in red. I just reversed the signs. So x is less than 2, x is greater than 9. Is it possible for x to be less than 2 and greater than 9 at the same time? No, that's not possible. So this is an or situation because x cannot be both at the same time. So you would just write this like this: x is less than 2 or x is greater than 9. So that's how that looks. So let's take a look at solving some of these compound inequalities. The first two examples are and examples. So we'll look at this here. And so you see again, so we have x minus 3 in the middle, and then on the left a negative 5, and on the right a 4. And so when you solve a compound inequality and, you're kind of working like from the middle out. So how am I going to isolate this x? Well, I have to undo negative 3. How do you undo negative 3? By adding 3. And usually you just can add 3 to both sides, right? But now there's kind of like 3 sides. There's the middle, there's the right side, and there's the left side. So I'm going to add 3 on the right, and I'm going to add 3 on the left. These 3's cancel out, leaving me with my x in the middle. And negative 5 plus 3 is negative 2. And 4 plus 3 is 7. So here's my solution to the inequality x minus 3 is greater than negative 5 and less than 4 is x is greater than negative 2 and less than 7. So now we can graph that. How are we going to graph that? When you graph an and, you're graphing the intersection, the overlap. So first let's graph x is greater than negative 2. Since it's not or equal, we're going to put a hollow circle on negative 2. And where are the numbers greater than negative 2? They're to the right, correct? They're to the right. So I'm just going to draw this arrow here like this. And then think about x is less than 7. Where's 7 is here. And again, it's not or equal to, so we're going to put a hollow circle. And then all the numbers less than 7 graph this way, to the left, right? So where do they overlap? In this space in the middle. So we just shade in this space in between the two circles. And that's how we would graph this compound inequality. Let's take a look at the next example. This is a two-step compound inequality. It's also an and. So let's take a look at it. In the middle I have 3x plus 2, and that is greater than or equal to negative 7 and less than or equal to 14. So what's going to be my first step here is subtracting 2 from both sides, right? So I'm going to, or from all three, from the middle and from the right and the left. So we're going to subtract 2 in the middle, on the right, and on the left. So in the middle, the 2's cancel out, leaving me with my 3x. And on the right, 14 minus 2 is 12. And on the left, negative 7 minus 2 is negative 9. Then my next step is I need to divide by 3. So again, I'm going to divide by 3 in the middle, on the right, and on the left. So my 3's cancel out here, leaving me with x in the middle. 12 divided by 3 is 4, and negative 9 divided by 3 is negative 3. So you can see here, now my solution is x is greater than or equal to negative 3 and less than or equal to 4. So now these are or equal to's. So when I go to graph x is greater than or equal to negative 3, I have to put a solid circle on negative 3. And the reason why we use a solid or a shaded circle on negative 3 is when it's or equal to negative 3, this number is actually included as part of the solution. And again, all the numbers greater than negative 3 are to the right here. And if x is less than or equal to 4, again, it's going to be a solid circle on 4. And all the numbers less than 4 are to the left. So our graph is the overlap, the intersection between these two. So the graph is the area here in between. All right, so let's take a look at some OR situations. And here they are right here. Notice that they're not combined. It's OR, and you're just kind of solving each one separately. So here I have x minus 6 is greater than or equal to negative 2. What are we going to do? We're going to add 6 to both sides. And we have here x is greater than or equal to 4. On the other side, we have x minus 4 is less than or equal to negative 6. So we're going to add 4 to both sides here. And we get x is less than or equal to negative 2. So again, think about this. It's impossible to be greater than 4 and less than negative 2 at the same time. So what do these graphs look like? Well, let's take a look at our greater than or equal to 4. So again, it's an or equal to, so we're going to put a solid circle, a shaded in circle on 4, and greater than is to the right. Right? Greater than is this way. So we're going to kind of shade in all of this and put our arrow. But when we say x is less than or equal to negative 2, negative 2 is over here, solid circle, and less than is to the left. So we're going to shade this way. So if you can kind of see the differences that the ands, the graphs for ands overlap each other, and the graphs for ors point away from each other. All right, one more. So over here we have 4x minus 2 is less than 14. So we're going to add 2 to both sides. Just like we're used to, you should be used to this by now. We get 4x is less than 16. And then last step here is we have to divide by 4. We get x is less than 4. On the other side, 7x is greater than or equal to 42. We just have to divide by 7, and we get the answer x is greater than or equal to 6. So again, impossible to be less than 4 and greater than 6 at the same time. So let's take a look at our graph. X is less than 4. This is not an or equal to. So we're going to put a hollow circle on 4, and less than moves to the left, so we're going to shade this way. We're going to shade to the left and draw our arrow. And then x is greater than or equal to 6. So since it's or equal, we're going to put a shaded circle, a solid circle on 6. And we're going to draw our graph pointing to the right because greater than moves to the right. And again, since it's an OR, the two graphs do not overlap.